Thanks everyone for joining me in this session. From chaos to clarity. So let's understand the first 3-4 letters, the chaos to clarity. So what's the main problem when we are building ML workflow or ML pipeline? We have raw data, but those are not enough to train a model or make a very fine-tuned model and then deploy it, right? So this is what we are talking about, how we can do those things in a simpler way using Kubeflow and Kubeflow notebook. Yeah, my name is Shekhar, currently working in data and AI side. I really like open source and love to contribute to open source projects. This is my LinkedIn QR code, so feel free to connect. And if you have anything, we can surely connect later on. Cool. So this is the agenda, one-stop platform that we are talking about Kubeflow. The different approaches, we have Jupyter notebook and how it is different than Kubeflow notebook. What are the benefits that we get from Kubeflow notebook? When I was saying data processing, we mainly think about something like Spark, which can do data processing in a scalable way and also maintain very well life cycle of the data processing, right? Later on, we will see the roadmap, the contributions, how you can contribute, how you can check out the Kubeflow community page and get involved. So when we say one-stop platform, what do we really mean? So when building ML workflow or ML pipeline, we have a couple of steps. We have a couple of people involved to building those pipelines. Start with raw data that is coming from our devices, like whenever we are clicking something, we are watching something, there will be some engagement, there will be some clicks events, there will be some impressions. Later on, those raw data will be something fine-tuned or done some pruning on top of it, so that it is features are extracted for doing any kind of ML workflow or ML predictions, ML model training basically. And then we have the deployment. Before that, we have obviously training, then fine-tuning, the deployment, and the maintenance part as well, the operational stuff. So there are a lot of people involved, right? From data engineering to machine learning engineer, then LLM or MLOps, and the SREs, DevOps tools, and the support team who are managing the overall system. To have one single platform, or at least the vision of having a single platform, the Kubeflow provides different capabilities and the components using which the respective people can work on their own component. So let's say we have data source, we have data engineer who can do things using Spark. There will be ML experiments going on using by data scientists or ML engineers or AI engineers, either using Kubeflow notebook or using Kubeflow SDK using pipelines, right? There will be fine tuning or hypertune parameters tuning, right? That can be done using Catlib. That is another component from the Kubeflow community. There is trainer. So mainly Kubeflow uses PyTorch, which is very distributed way of training any model. Model registry, if you want to store your model somewhere and serve it in an endpoint, so that your applications can be using those endpoint and use for any kind of predictions or maybe embedding generation nowadays using LLM. So the blue one is basically the primary part. The greens are kind of secondary, where we are either doing or something like optional. These are some kind of APIs that users are actually looking into, Kubeflow pipeline, the SDK. So this is new thing that we are trying to build. I will talk about it later on. Okay. I hope it is visible. So I was talking about different layers, like data layers, the orchestration through pipeline and building the workflow. Data processing using mainly Spark, I'm talking here. And then the development and the model training and the management of the model. This is also very much important. So here we are focusing not everything, but only the data processing part, which is required good amount of resources. Like you need CPU, you need computation power, you need memory to load that and do any kind of aggregation or processing based on that. So let's think how we can achieve that. Yeah. So before that, let's think. So why am I saying platform? So that every respective people can work at their field without worrying about the infrastructure of it. So why Kubeflow? Kubeflow provides an interface. These are the main interface for the users and the developers. These are kind of abstracted. So we as a user will not be knowing under the hood how complex Kubernetes cluster is looking and what are the things like storage or monitoring part or authentication, how it is getting managed. So those are kind of abstracted, we never be knowing, but as a user we want to focus more on our core work. Like machine learning engineer will focusing on the experiments and training, and then the DevOps and support operation side, model registry and the serving part. So yeah, once this is very clear, let's understand the challenges that I was talking about. So let's start from here. When we are trying to do any kind of data processing, we need to have enough computation and memory. So a single machine cannot hold those amount of data. That is one. So that means data side needs to understand the complex infrastructure somewhere. The second part is scalability. We are not sure how much resources we need. So we want some kind of auto scaling part that is already solved somewhere here and there using Kubernetes, auto scaling, and there is Spark which can spin up number of executors to process them. And once that is done, we want to have some kind of debugging so that we can understand what happened under the hood when we are doing data processing, and we can we improve the overall data processing part. So this is about main problems. Let me touch upon few things. Can we solve these things? Is it already solved somewhere? We have Kubeflow notebook using which we can spin up a Spark application, do the things. Okay, not sure. Plus plus. Yeah. I don't think we can scroll command press, but this is yeah, it's I will share it like later on as well. We will think more about this. But yeah, I was talking about is it solved problem or we reinventing the wheel? So we have Kubeflow notebook using which we can run Spark application.
Cancel the slideshow and just change it.
Yeah, slideshow. I'm not. Oops. Okay. Yeah, it is. Actually, it is Comet. That's why even I was. Okay, hopefully it is visible. So, yeah, using Kubeflow notebook, we can have an image template and we can spin up Spark application under the hood. But here as well, we need resource and auto scaling part. When we spin up a Kubeflow notebook, it launches a pod and it is doing all the processing at the single pod. That is not scalable, which is not isolated from the Spark executors as well. The same thing, whenever we have Jupyter Lab or Jupyter Hub, it can launch a kernel and run it somewhere, but still that particular instance will be doing all the work. So if there is heavy load, it is not very auto scalable. yeah, these are all handling the life cycle of the application. Okay. Okay. So some of the differences I was just talked about. When we are using Jupyter Notebook, it is kind of local machine with limited resources. But in Kubeflow, it is because of cloud native, we are on-demand scaling. There will be some persistence storage. We want to store it somewhere so that when we come back, we would like to, we do not want to retry the same thing again. So that's why those storage also much needed, and it is shared storage. When we say shared storage, that means multiple users can use same notebook and can run at their end. So those are kind of shared storage, and those are multiple users can be authenticated to use those notebook and see the outputs that we are getting from the notebook cell. So same thing about collaboration. So as we can see, Kubeflow notebook, in a simpler term, Kubeflow notebook comes with a template, and it is more collaborative approach to have a notebook and can share by multiple peoples and can be useful. Okay. Okay. The another important features that Kubeflow provides, Kubeflow notebook provides, as I mentioned, Kubeflow have multiple components, and each component doing their own work. But if you want a single platform where we want to do some kind of experiments, Kubeflow notebook is the way. And this is having good compatibility with all the components, because this is how we are deploying it, and all the access of different APIs, data registry, training job, catlib APIs, those will be installed already in the notebook. So those are kind of template. So let's say I just want to use SciPy. I will choose SciPy image in the notebook, and one notebook instance will be created. That means that have enough capability to understand all the APIs plus SciPy installation. Same for let's say I want to have neural network kind of experiments, like some model training. Kubeflow notebook have image for PyTorch. So PyTorch version of the Kubeflow notebook instance will be created, and that have enough APIs to use all the internal components. Okay. So we are still working on that actually. It's not fully production ready, but it's still going on. As I saw some of the parts, but still things are not very production ready and not very, every components are connected. So some of the works that has been done in this Google Summer of Code 25 by one of the contributor. This is one of the blog. If someone wants to read, go through it. You can just write Kubeflow notebook and Spark inside the Spark operator. Let's talk about this image. Okay, so as I mentioned, somehow we need to isolate the execution part, the data processing execution part. If it is running in the same node, then we cannot load whole bunch of data or doing some kind of processing there. We want some kind of isolation that it will be running somewhere in the cloud, in the Kubernetes cluster, and we will be just getting the results. So the computation and the memory part will be isolated, and the Kubeflow notebook will never die. Here, two users are trying to use Kubeflow notebook. They have their own instance of Kubeflow notebook, and once they want to run some kind of data processing using Spark, they will spin up, they ask for, okay, I want Spark kernel. We are integrated with Jupyter Enterprise Gateway. That is useful for spin up a Spark application somewhere in Kubernetes cluster using this internal kernel manager and process proxy. Once that is done, we have Spark operator or Spark cluster already running in our namespace. If it has enough authentication and authorization, it runs the execution part here, get the result, and users will be seeing in the Kubeflow notebook. So in this solution, we are not running data processing in the same machine. We have isolated the data processing part and getting the result in an efficient way. So yeah, this was about the things that we are working under the Google Summer of Code. So this was the project proposal. So as I mentioned, I'm into one of the strand, but we are still working on that. In the next year again, we are working on that. There is Kubeflow SDK also coming up. So I already talked about Jupyter Enterprise Gateway somewhere, why it is important and why we are trying to integrate with Kubeflow Notebook. So this isolate the kernel manager. So when we want a kernel like Spark kernel basically, it goes to Spark kernel manager and wants and fetches, talks to Spark cluster that I want to run some Spark application. Once then all the Spark things that come into picture like driver and executors, their resource managers check if we have enough resources. If enough resources are available, then it says okay, you can execute your Spark application in certain number of containers. Once those containers are launched using CRDs, those are now executed. All the Spark code, Spark applications will be executed, get the result back to the kernel and kernel back to notebook. So yeah, this is how we are trying to isolate most of the execution and data processing and the ML workload as well. I have sequence diagram, so don't worry if it is looking a little bit hard. Okay, so this is what I was talking. We are like data scientists, ML engineer, or doing any kind of experiments. We go to Kubeflow notebook. They say, okay, I want a Spark kernel. Let's go to Enterprise Gateway. Enterprise Gateway is responsible for giving me Spark kernel back and results back while executing it under the hood. So if we isolate this particular part, how Spark is doing, those are anyways Spark side of the design, but Enterprise Gateway is very useful for any kind of kernel management as well as the life cycle of the Spark application that is running inside. Here as we can see, when we are talking to Enterprise Gateway, we are also telling what are the resources we need, like driver need 4 core, 8 GP memory, a number of executors and total number of cores and memories needed. In that way, we are making sure that our notebook instance will never die. Those resources, if available, will be allocated somewhere in the Spark cluster, and Spark cluster obviously running in Kubernetes namespace. So this part is important. Let's think, capture this in memory so that we can later on talk more. But yeah, this is what the solution looks like. Okay, so there are a lot of projects and a lot of things we are trying to do, and we're still working on it under the Google Summer of Code and outside Google Summer of Code. And next year we are also preparing for that. I just want to highlight about Kubeflow SDK. So this is something new. This also has similar vision, one-stop platform where user will be using Kubeflow APIs for any components like cat lab, Spark, pipeline, or any kind of serving mechanism as well, and the training obviously. So this is enhancement proposal. Under that, mainly I'm working on the Spark client of it, since we know that if it is a raw data, we cannot do much in terms of training and the accuracy will not be very good. So this is what we are trying to do. We will be having a single kind of API and all these Spark components, just like whatever PySpark provides, we will be having using kf.spark. But on top of that, we have all the configurations, all the volumes related stuff, all the installation already done in kf.spark, and we will be using, we will be able to use it. So in this example, we are just reading from a S3 location and then doing some kind of processing using run method, or we might be having some processing, and that process data will be went to trainer API for any kind of training part. So in that way, either it is data scientist, data engineer, or ML engineer, they will be using a single platform. Yeah, I do not have demo as such, but feel free to talk or ask any question. Go to Kubeflow community. You will find bunch of calendar invites under Spark operator, under Notebook, and under Kubeflow SDK and ML experience. So I would like you guys to go and check it out. If you have any questions, you can definitely ask anywhere. Even I join regularly. It is mainly bi-weekly, mainly on happening on Wednesday or Thursday. So anytime if you are available, please join it around 8 p.m. or 8:30 p.m. There are a lot of things going on, and we really need contributors so that we can make Kubeflow more robust and more powerful. So yeah, that's it from my side. If you want to connect, we can connect here. If you guys have any question, I can take it. But I know it is too much, but I try to simplify some of the things. As I mentioned, things are already going on. The contributions are going on. We have some of the components ready that can be in an experimental phase.